All right, so for our lesson today, I wanted to start by recapping the equations that I've asked you to solve so far. I tried to keep it pretty basic, stuff that you didn't necessarily need a lesson on, and several of you haven't turned it in, so make sure you go back and do that so I can give you credit for it. To start with, I asked you guys to solve one-step equations, or at least what I'm calling one-step equations. Pretty straightforward, some variable plus or minus equals some other number. What you have to do in that case is whatever operation is in the problem, your job is to do the opposite of that. So in setting this one up, I subtracted 7. I need you guys to add 7. What that will do on the left-hand side is cancel out the 7s. And when you add 7 on the right, you've isolated your variable. That's what you're trying to do when you solve an equation, is get the variable by itself. So my x being isolated on the left, 12 plus 7 on the right, my answer is 19. When you input these answers, you do not need to include the variable. A couple of you did that, which is fine. I caught it this time, but just make sure you're inputting the answer, 19, not x equals 19. On Friday, I asked you guys to take it up a notch and solve a two-step equation. Basically, what that means is you've got something with a coefficient out front. Right? The coefficient out front is something that you'll have to deal with before you can arrive at your answer. So let's take a look at this one. Again, I'm trying to isolate the variable, so I need to take care of the 2 and the 5, both on the left-hand side with the x. The question is, which one do I deal with first? The multiplication, the coefficient attached directly to the x is always the one you take care of last. So I'm going to subtract off my 5 here, be left with 2x equals 8, and then when I divide out my 2, I'm left with my answer of 4. Okay, again, Google form, just put your answer in as 4, not x equals 4, or it will flag it as incorrect. So today, taking it up a notch again, I'm going to ask you guys to combine like terms. When you're looking at an equation, your like terms are any terms that have the same variable, or maybe they're terms that don't have variables at all and they're just constants. So in this case, the 3a, the 12a, the 54a, those would all be like terms, and all these x terms would be the same too. So when you've got that situation where you've got more than one occurrence of a variable, what do you do with it? Well, it usually tells you in the problem what you should do with it. In this case, you've got 2x plus 3x. You literally add them together. The variables don't change when you add. Some people like to throw an exponent in there. That's for multiplication, which is something we'll deal with down the road. But all you have to do is literally add your coefficients together. Pay attention to the signs on your coefficients. If you goof that up and you don't include the negatives in there, it'll obviously throw off your answer. So in this case, I'm adding my 7x and negative 7 and negative 4x together, and negative 11x. Again, no exponents. Negative 4 plus 3, negative 1x on the last one there. So what happens is when you're looking at an equation that has more than one occurrence of your variable, find those terms and then add them together, paying attention to their signs. 4x and 6x, add those together, 10x. Everything else drops down from your equation. Once you've got everything carried down into the next line of your equation, just do it like we did the last example. Subtract 4, and what you're left with should divide by 10. We won't always have nice whole number answers like this, but for right now, we'll just keep it nice and simple. No decimals, no fractions to worry about. Okay. If you get a decimal or fraction on these, at least for now, you might want to go back and check your answer. Until you get used to it, I'm gonna take it easy on you. Try and keep your answers as whole numbers. Same thing here. Isolate your identify your like terms. Add them together. 4 plus 6. Give you a 10R. Okay. When you take that next step and subtract your constant off the front here, a lot of people seem to think that when they get a 0 in an equation, they've made a mistake. It's a number. You're in a math class. It's okay. So when I divide both of these sides by 10, 4, where'd that come from? Okay, I got in a hurry and made a mistake. Take your time. Don't rush through these. There's a few questions to answer in your Google form. Check those out. If you have any questions, feel free to email me or put your question in the math questions section of your class. Thank you.